Hi, it's Jan Beta, and today I'm gonna future-proof this Commodore 64 board, which is the board of my main machine. And yeah, first of all, I'm gonna replace all the electrolytic caps. You've seen me do this before on an Amiga and stuff. Maybe I will link in a video here. And I also did this on my ZX Spectrum. I've had these actual caps lying around here for quite a while, so yeah, it's about time I do this. Yeah, so got the desoldering station heating up here, and I'm gonna recap this board. So that's done. So yeah, what I also want to do is to apply some heat sinks to some of the chips here that get particularly hot. Yeah, most of the chips get quite hot, so I think the WIG 2, which is the video chip, definitely needs some heat sinking. The PLA needs some heat sinking. The SID needs some heat sinking. I guess the CIAs could also use some heat sinking. The processor, maybe. These are basically ROMs, so yeah, they don't necessarily need something. The kernel ROM, the basic ROM, and the character ROM. I don't know which is which off the top of my head. This is the kernel ROM, I think it's socketed on this one. Yeah. I think what I'm going to do is to test if I got all the caps in the right direction and yeah, power it on for a quick test, and then apply some heat sinks. Okay, so here's the smoke test, as we electronics people say. So let's see. Yeah, and there we go. It still seems to work. Yeah, and basically, I think I'm gonna leave this running for some time and see which chips get particularly hot and heatsink them then. So I had this running for a couple of minutes, and I'm gonna use this little cheapo infrared thermometer that I didn't even peel off the foil, just noticing, to check the temperature of some chips. The VIC 2 that's nearly 50 degrees I got there at some point. Yeah, that's it. 48 degrees Celsius. So let's check the PLA. The PLA is at about above 32 or something. So the SID is at about 38 or something. The processor has nothing to do, but it's still at nearly 40 degrees. The other ones are a little above 30. So what is usually recommended is to at least, yeah, that's nearly 50 degrees, which is way high, to at least give this a little heat sinking, which is done on some board revisions where there is a shield that has a little copper tab that touches this one and gives it at least some heat sinking. Interestingly, fellow YouTuber Mindflare Retro made a video where he actually tested it with the PLA, but it's probably the same effect for the VIC-2, where he actually tested if the shield has any effect, any heat sinking effect on the temperature of the chips, and yeah, it doesn't. It nearly has no effect at all. He put a little probe under the PLA in that case, and yeah, I will link in his video. It's very interesting to see how badly this really worked. So everybody was thinking it was a good idea to give it some heat sinking, but yeah, if the whole heat sinking doesn't work, it's pretty pointless. So what I'm gonna do is to use some of these, which are aluminium heat sinks that you can buy for, I think these are ones for graphics cards or something. You can buy stuff for ICs with a little heat conductive double-sided tape on there. Make sure it's quality ones, so they have, I think it says 3M, which is good tape, so it will probably last for a while. If these come loose, you most likely have a problem, so they might fall on some pins and short stuff out because they are made of metal. So yeah, you don't want that to happen, so better buy some with good rubber pads. So what I'm gonna do first is to apply some isopropanol. I have a little cotton pad here, and yeah, I'm gonna wipe off all that's on there maybe to make the sticky tape. Oh, look at that, it was painted in some way. It's kind of blue. Gonna wipe it off so that the double-sided tape will hold on there quite well. So I think maybe I'll put 3 of those on here like this, because this one gets really hot. And there's our sticky tape there. And it's supposed to be, wow, yeah, that's sticky. So and I press it on there for some seconds, which is not easy because those fins are quite sharp. Ouch. So yeah, but that's not going anywhere, I guess. Let's fit the other ones. So this basically repeats for the other chips, so I'm not gonna I'm gonna speed this up a little, I guess. I'm gonna use one of those for each of the chips. I think it makes sense to put these in the middle of the chip there, because the die where the transistors and the circuitry, the miniature circuitry is located in the middle of the chips. So it probably makes sense to apply the heat sinking there. So one more. Okay, so as you can see, I have all the main ICs heatsinked now, which should make them run a lot cooler, I guess. I hope, at least. Okay, so I've had this run for some time. And yeah, the heatsinks are warm. Let me turn on the light here. So the VIC 2 is, it's 36 degrees or something like that, which is way better than over 50 degrees. See, the PLA is around 24, 26. SID is around 30, maybe. The processor is around 28 or something like that. Yeah, but the wick, it's really cooled down. That's great. So this will probably last way longer. But this runs way cooler than before, which is great. So these ICs, they die mostly either of electrostatic discharge when you are not careful when handling them, or they die of heat over time, which this probably prolongs their life quite a bit. If you want to keep the original chips alive, I highly recommend getting some heatsinks, especially on the older models of the Commodore 64. The younger ones, especially the last board revision, that is the smaller board with the combined chips. It has larger chips that combine some of the older chips in one. These are made with a more modern approach, so they don't run as hot as the old ones and last way longer, I guess. So they are not as prone to dying of heat as the old ones, but yeah, they also could use some heat sinking. So, and I kind of forgot that there are caps in here in the little RF modulator that do affect the video output, no matter if you use the RF modulator, but they are basically the same. They are hooked into the same circuitry that is responsible for the video output. So if you're not using the RF output, you should still recap this. I think there's quite a few small caps in there, and yeah, being in this metal can, they probably get quite hot. And yeah, so I'm gonna do that too. And there is, of course, there's this little tab here that is soldered on, so we'll probably need quite a lot of heat. And I'm quite lucky. I'm quite happy that I have my desoldering gun here. And what would do? Yeah. So there's our little tab that we just lifted. And now we should be able to just lift this up. I think, yes we are. And it's just soldered to this metal can here, which is the potentiometer to adjust the channel in this case. So yeah, and there's quite a few, 1, 2, 3, 4 little caps in there that need replacing, I guess. So how do I get this out? I'll have to desolder the whole box, I think. It's a bit of a pain, really. So, yeah. see. These are little solder points here. And as you may be able to see, there are these little metal tabs that are twisted a bit. Just use some needle nose pliers here to twist them so that they fit through the holes there. I think we have to take this whole apparatus off here. So in the front, yeah, there we go. There we go. There it is. And we have to, wow, we have to take off the whole bottom plate here. It's quite an operation. Okay, so let's do this. So switched off the desoldering station so we don't have the annoying noise here. And this looks like it has these little tabs here, like it just lifts off, like the top. And I'm going to be a bit careful, because you never know. Well, this is on there quite tightly. Is it soldered? Oh, it's soldered on this point here, so we have to take this off. Yeah, there we go. It's, yeah, similar to the top. There's a little protruding latch here that is soldered on to this, I guess it's the ground or something like that, to shield this. Yeah, this is the PCB exposed, so we can yeah, desolder some caps there, I guess. Yay! And look at that, it has the farad in NFD and it has the voltage in VDC, and it has the positive side marked, which is very, very old school. And what do you know? 417 16 volts, and this was 10 volts. Yeah, so this, it's always okay to use a higher voltage, and it's always okay to use a higher temperature rating. It's always good, in fact, to use, yeah, the one that was in here was 10 volts and this is 16 volts. And it's important that you use the same capacitance. This was a 470 microfarad one, and the MFD means the same as the little micro sign. That's more modern. And yeah, so there's a minus sign on here even. On most modern electrolytics, there's the negative side is marked. So on the old one had the positive side marked with a plus. Most of the times you see the plus and the minus there. So this would go like this. Don't get confused there, because yeah, it's polarized caps are very important to put in the right way. So this is all recapped. Let's reassemble it. Another common thing that kills Commodore 64s is these things here, which are supposed to supply the voltage to these machines. But yeah, these, especially these old ones, are really, really poorly constructed, and yeah, they are really old. And if some component in this fails, it often gives an overvoltage, and the overvoltage quickly kills some of the ICs in here. And to prevent that from happening, there's quite a few possibilities. You can buy some quite expensive, or build yourself some protection circuitry, or build your own power supply, which I'm gonna do at some point. And there's also a method that I'm gonna try here in this video, which is quite, yeah, it's a very cheap and quick method to protect the Commodore 64 from overvoltage on the 5-volt line, which is the line that powers all the ICs and kills the ICs if the line fails. So what you need is one of these transient voltage suppressor diodes, P6KE. It's 6.8A, which means that the diode becomes conductive at 6.8 volts. Most of the chips here can take 7 volts for a short period of time before they break. So what these do basically is you connect them over, so these are the power lines, negative and positive, and you connect these diodes across there, and the diodes become conductive if a certain voltage is applied. So these become conductive at 6.8 volts, and basically what they do is they short out the power lines. They short the power line, the 5-volt rail in the Commodore 64 case, to ground. And yeah, the diodes blow at some point, or the fuse in the power supply blows. So this will protect, in a very harsh but very easy way, easy to achieve way, your ICs on the Commodore 64 board, because they can take voltage bursts up to 7 volts or something, and they can operate at that level. And if it goes over the 7 volts, this will basically blow the fuse. So that's how this very crude but effective, and they do it very fast, effective kind of protection works. So you don't lose the ICs, which are very expensive and they are not made anymore. You lose this and maybe a fuse. Or you lose a fuse and maybe this, which is a few cents, not more. And the place you insert these is these little pads here. Here's the LED, power LED connector. Let me zoom in a bit. So here's the place where you insert the TVS diode. The negative side is this pin here, and the positive side this pin here. So you will need quite a good soldering iron, because there's a large ground pad there on one side. Yeah, actually both are quite large, so you need quite a lot of heat. I hope my iron will handle this. I think so. So I'm going to 450 degrees Celsius here, which is quite hot. So let's see if we can fit the diode in there. The negative which is the side with the little ring on it. You can see the marking here. Goes there to the right in this picture. So let's see. So it's a bit big, the diode, but that's good because if something goes wrong with the voltage, it's gonna burn, and so it's common practice to stand components that will get hot or are likely to burn a bit off from the board, which is only, yeah, to not damage the board, which would probably not matter in this case because it's only a big ground pad, and on the other side there's nothing highly important on this spot on the board. Yeah, let's solder it in. And in case you're wondering, I'm not gonna test if this really prevents the Commodore 64 chips from failing. This is just a last line of defense, I would say. Yeah, I'm not gonna test it on a working Commodore 64. So let's see, we'll need some heat to solder this on here, I guess. Yeah, so I guess that'll do. Okay, so let's test this. And there we go. It seems to still work fine with all my refinements in there. So yeah, I guess I'm gonna put it back in the case and play some games, maybe. Ta-da! So I'm gonna celebrate having this reassembled by playing a little Bare Essentials. I actually bought the physical disc edition, which is very nice. Let me at least hold it up to the camera. So this is the actual package it comes in, and yeah, it's really, really lovely, and you get some stickers and stuff like that, and you get a physical disc. Whoa. And of course you get a very, very, very lovely little game that comes in a special edition that is only available if you buy the physical edition. And it's even nicer than the edition you can download for free from pawnsoft.uk, I think. Is it Pawnsoft UK? I will link it in. And yeah, basically I highly recommend getting this and supporting the people who made this. And I totally suck at it, as with most games. Yeah, just listen to the music. It's so lovely. So yeah, anyway, this Commodore 64 will probably last some time now. There are some things that you could replace as a preventive maintenance kind of thing to do. There are, I already mentioned the rectifier, that those break with time because they run quite hot. There are the 78 7805 and 7812 voltage regulators that could be bad with time, and yeah, you could replace those. I've left them in for now. I think I might replace them later, but for now, yeah, this seems to be quite... Oh, yeah, did I mention I suck at this game? So I won't bother you with more of my gameplay now and just say, yeah, basically, thanks for watching. Comment, give this a thumbs up. It helps a lot on the YouTube ranking algorithm. I hope that some Commodore 64s survive. Maybe because someone saw this video. Anyway, thanks for watching. Hope to see you again. And yeah, stay tuned for more. Thanks. Bye.